This is Geometry Unit 10, Lesson 7 on rhombi and squares. Rhombi is the plural of rhombus. More than one rhombus are rhombi. So a rhombus is a quadrilateral with 4 congruent sides. It is, since it has congruent sides, equilateral. A rectangle was equiangular. A rhombus is equilateral. Okay, now why does that make a rhombus a parallelogram? Well, if it's equilateral, both pairs of opposite sides are congruent. So if a rhombus is a parallelogram, it will have all the properties of a parallelogram. Opposite sides are congruent and parallel, opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. So it's a parallelogram, so it has all of those properties. Now, some special properties of the rhombus, what makes it different from just being a parallelogram, is a rhombus is equilateral. We just talked about that. All the sides are congruent. Also, the diagonals of a rhombus are perpendicular to each other. This is an important one. This one is what differentiates a rhombus from other parallelograms, is it has perpendicular diagonals. And the diagonals of a rhombus also bisect its angles. So we are going to look at these different properties and why they work. So we are going to prove why these properties are true for a rhombus. Alright, so the first thing that we're going to prove is we are going to prove that the diagonals of a rhombus bisect its angles. So if we have a rhombus ABCD with diagonal AC, we want to prove that the diagonal AC will bisect angle A and angle C over here, so DAB and BCD. We were going to prove these here. Now, how do we prove the angles have been bisected? We want to prove that these two angles are congruent and these two angles are congruent. Okay, so let's see if we can do that. So we are given a rhombus. And we have diagonal AC. And there's my picture. That's given. Okay, now, by the definition of a rhombus, what do we know about a rhombus? It is all sides are congruent. So we can say that AB, AD, DC, and BC are all congruent. Okay, because all sides of a rhombus are congruent. AB is congruent to BC, is congruent to CD, is congruent to DA, because all sides of a rhombus are congruent. Okay, now if I want to prove that the angles are bisected, if I want to prove these two angles right here are congruent, and these two angles right here are congruent, probably I want to prove the triangle's congruent. So what am I missing to prove the triangle's congruent? Well, how about AC? By reflexive. It's not the only way, but that's one way. So by reflexive, that is true. And now the triangles are congruent. Now be careful how you name the triangles. A, B, C, because I want A to correspond to here. A, B, C would correspond, or would be congruent to A, D, C. And we just proved that using side, side, side. So by side, 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 those triangles are congruent. So what does that tell me about this angle and this angle? Well, since they correspond, they're corresponding parts. So that means that angle BAC, this angle up here, is congruent to angle DAC. And angle BCA and DCA are congruent. And all of those are by CP/CTC. So if those two angles are congruent, and these two angles are congruent, what does that tell me about AC? AC bisects angle BAD and angle BCD, because a bisector divides an angle into two congruent angles. So we've just proved it. So now we know that when you have a rhombus, the diagonal will bisect its angles. So the second theorem about rhombi that we want to prove is that the diagonals of a rhombus are perpendicular. So we have a rhombus, ABCD, with diagonals AC and BD intersecting at E, and we want to prove that the diagonals AC and BD are perpendicular. So we have to prove that we have perpendicular lines. We have to prove we have right angles. So we have to prove that AC and BD form right angles somehow. So somehow we have to get a right angle in the middle. Okay, so if we have a rhombus, ABCD, and we have the diagonals AC and BD intersecting at E. And that's given. Okay, now my goal is to get a right angle. Well, perpendicular lines make right angles. That's what we want. How are we going to get right angles? Well, if we could prove that these two angles right here are congruent, that would be very handy because then it makes a line and they would be supplementary. So let's see if we can do that. What triangles do we have to prove to do that? Well, we want to prove triangle ADE and ABE. So let's see if we can do that. All right, now, first of all, what do we know about a rhombus? All sides are congruent. But what sides do we need? We just need these two right here. So AB is congruent to AD because all sides of a rhombus are congruent. I just need those two. So there we go. Okay, now notice these diagonals intersect. What do diagonals do if it's a parallelogram? Well, it also, because a rhombus is a parallelogram, they bisect each other. So that means that DE is congruent to BE. So that tells me the diagonals of a rhombus bisect each other. Technically, a parallelogram does that, but a rhombus is a parallelogram. All right, and then to prove the triangles, if we can get AE is congruent to AE by reflexive, we have proved the triangles congruent, the ones ADE and ABE, by side, side, side. Now we can say that these two angles right here are congruent by CPCTC. Angle AED is congruent to angle AEB. And that's by CPCTC. Now, what do we know about those two angles? Where are they? They're next to each other. They're adjacent angles that make a line. So what else do we know about them? We know they're supplementary. AED is supplementary to AEB. All right, because adjacent angles that make a line are supplementary. They're supplementary. So we proved they're supplementary and they are also congruent. Well, we proved a theorem when we did the squares. Remember, if angles are supplementary and congruent at the same time, then they must be right angles. Angle AED and angle AEB are right angles. Because congruent angles that are supplementary are right angles. Okay, and where do right angles come from? They come from perpendicular lines. So if these two angles right here are right angles, that means that AC and BD are perpendicular. So we can say that AC is perpendicular to BD because perpendicular lines form right angles. And we have just proved that the diagonals of a rhombus are perpendicular. Okay, so those are our two important properties of a rhombus. Besides being a parallelogram, it also has perpendicular diagonals, and the diagonals bisect each other, and all the sides are congruent. All right, so now let's apply the properties of a rhombus to this diagram. Okay, the diagram shows a rhombus with both diagonals drawn. Find the values of x, y, and z. Okay, so since this is a rhombus, what do we know about the diagonals? We just proved. The diagonals are perpendicular. So that means that's a right angle. So the diagonals are perpendicular. So that means that x is equal to 90 degrees. Okay, now, if this is 90 degrees, right there, what do we know about the diagonals? What do they do to the angles? The diagonals bisect the angles in a rhombus. That was the other proof we did. So the diagonals bisect angles. So if this is 25, that means that y is also 25. Okay. Now, we also know that this is a triangle. All right, so this is 90 degrees right here. These two triangles are actually congruent. So how many degrees in a triangle? There's 180. So the sum of the angles of a triangle equals 180. So if this one is 90 and this was 25, that's 115. So it would be 180 minus 115, and that makes z equal to 65. So we just found all those measures without having to do anything else. If you know the diagonals are perpendicular in a rhombus, these are all right angles. The diagonals bisect each other, and the sum of the angles is 180. So using those values. So we actually have three ways to prove a quadrilateral is a rhombus. So a quadrilateral is a rhombus if you can prove you have a quadrilateral that is equilateral, that has all four sides congruent. If you can prove it's a quadrilateral with four sides congruent, you can automatically say it's a rhombus. Now, the second way to prove a rhombus is to prove how it's different from a parallelogram. You have to prove it's a parallelogram with two congruent consecutive sides. So all you have to prove is that you have a parallelogram and that the one pair of sides next to each other are congruent. Because if one is congruent, the other won't be. So all you have to prove is like two like this, one here and one here. And the other way to prove it is to prove it's a parallelogram with perpendicular diagonals. Now these two, it's important, you have to have a parallelogram first. The first one, the equilateral one, you only have to have prove four sides congruent. So there is more than one way of doing this. So what we're going to look at is a geometric proof of a coordinate geometry proof in the next class. And we're going to look at this and solve it and prove it's a rhombus by one or more of these methods. So we will do that in class the next day.